So today we begin a different chapter. We're starting to talk about terminating and repeating decimals. Now I'm going to tell you that this lesson is not difficult. It's actually quite easy, but there's lots and lots of little tiny details that you need to pay attention to. All right, so let's talk about some vocabulary to start with. Terminating decimals, all that means is that they end. They have an end. If you think about the word terminate, it means to end. You might have a terminal, a bus terminal or a train terminal. That's where the bus line or the train line ends. You might even know the bug extermination company, Terminex, because they put an end to your bug problems. So the opposite of that is a repeating decimal. And just like it sounds, the numbers are going to repeat. And it usually goes on without n. Sometimes you'll have one digit that repeats. Sometimes you'll have two digits that repeats. Sometimes you'll have lots of digits that repeat. To do that, we use something called bar notation. It's a shorthand form that tells you what digits will repeat and repeat and repeat. So I have some examples here that I want to talk about. In our first one, these would all have zeros in front, of course. In our first one, we have 0.6 repeating. Because the bar is over the 6, it means that I will write as many sixes as I could possibly imagine without end. Okay, now eventually you run out of paper, so we put the 3 dots to show that it goes on and on and on. Now, for the second example here, the bar is only over the 3. So that first 0 after the decimal is going to stay, and it will not repeat. And then it's the 3 that will repeat over and over and over until I run out of space. The next example, the bar is over both 4 and 5. So both of those will repeat in a pattern. 4, 5, 4, 5, 4, 5, etc., etc., etc. And then for our very last example, the bar is only over the 2. So the 1 and the 6 will not repeat, but they still need to be there. And then the 2 will go on and on and on. Okay, so be very particular when you're writing things with the bar that you don't accidentally extend it further than you mean to. All right, some other little tidbits that you need to be aware of. We're going to start talking about signed fractions, fractions that have negatives. In a fraction, there are 3 places that the sign can go. It can attach to the top number, it can attach to the bottom number, or it can attach smack dab in the middle. All 3 of these representations mean -1/2. What you cannot do, however, is put it in 2 places, because this, although it looks like a fraction, is actually a division problem. And you know when you've got a division and there are 2 negative signs, this would be +1/2, which is very different than the 3 I've shown up here. Okay, so 1 sign, put it anywhere you want. As soon as you've got 2 signs, they can still go wherever. I could have a +1, a negative in front, and a -2. That's fine. But know that this only has 1. These are the same. And these all have 2. They're the same. But the 2 circled things are different. When you start talking about mixed fractions or mixed numbers, the negative sign needs to go in front of the whole number. So this would be -6.5. If I was to put it in between, it starts to look like subtraction. So this is not how we would do it. You would put the negative in front of any whole numbers. All right, so now that we've got all those little details out of the way, let's talk about converting. So let's say that you have a decimal and you want to make a fraction. Generally, especially for things that terminate or have an end, you're going to read what you see, read it correctly, okay? Not the point whatever, but actually use your place value. And then write exactly what you read. And then, of course, simplify. So here's my first example. Most of the time, our shortcut would be, 0.74, which is fine when you're trying to communicate. But to do this method, you have to read this properly. This is 0 and 74 hundredths. Well, I heard 74 hundredths, so I'm going to write it as a fraction like that. And then from there, I can simplify. So I would divide both by 2, 37, and then that is in simplest form. So 74 hundredths is the same as 37 fiftieths. Now, this is one that you probably already know. 0.5 is a half. But how do I read this properly? This would be 5/10. And from there, I can simplify and get my 1/2. So read what you see, read it properly, and then write what you read or write what you hear. Now let's go the other way. Let's say that you've got a fraction and you want to make it into a decimal. There's two methods. One, for a lot of them, seems a little bit more cumbersome. Most of us are just going to reach for a calculator. But if you can start to look for certain types of denominators, this first method is actually faster. Okay? You're going to try to make equivalent fractions where the denominator is 10 or 100 or 1,000 or something like that, some power of 10. That's method one. That doesn't always work. Sometimes, like for nines, to get it to be a power of 1,000 or a power of 10, the number is so ridiculous. So the other method is to simply divide. And I'm going to show you examples of both of these. Okay, so for our first one here, 3/10. Well, 3/10, that's already a power of 10. So I can simply write it in decimal form. 3 in the 10ths place. Put my 0 in front to be proper. Okay, does not get a bar because it does not repeat. This is a terminating decimal. Our second example, I'm going to try to get this over 100. Well, how do I get from 25 to 100? Multiply by 4. And you know what I do to the bottom? I must also do to the top. So 3 times 4 is 12. Well, how do I write 12/100ths as a decimal? 0.12, 12/100ths. Now, we have a mixed number at the bottom. I'm going to keep that -6, and I'm going to tackle just the 1/2. So I'm going to get a 10 on the bottom. I could do 100 or 1,000, but 10 is the simplest. How do I get from 2 to 10? Multiply by 5. How do I get, or what do I do at the top? Same thing, 1 times 5. So this would be 6 5/10, or 6 5/10, -6.5. I am going to give you a list of common fraction to decimals that I want you to memorize. We'll talk more about that tomorrow on the Zoom call. But when you memorize them, something like this, you don't have to go through all the work. You're like, oh, I just know 1/2 is 0.5. Okay, let's jump over to our division. If you've got weird numbers and you don't have a calculator with you, you got to go the old-fashioned way. Top number goes in, bottom number goes out. I can't do 3 divided by 8, so I'll add a decimal and a 0. Decimal shoots right up top. Now I have 30 divided by 8, and that I can do. So I'm going to get 3. 3 times 8 is 24. Add a 0, bring down. 60 divided by 8 is 7. 7 times 8 is 56. Still got more left. Add a 0. 40 divided by 8 is 5, and that will take care of it. This is actually one of the ones on your list. So instead of having to divide every time or even having to reach for a calculator, you just know that that's 0.375 or 375 thousandths. Okay. Now, 7/9, 7 goes in, 9 goes out. Add my decimal and my 0 because I can't do 7 divided by 9. 70 divided by 9 is going to give me 6. No, it's not. 63. 7 times 9. Oh, a 7 here. Sorry. It's a Monday, so that's a 63. We get 7 left over. Add a 0, bring it down. We'll get a 7 again. 7 times 9 is 63. Subtract. You're going to see that this is going to keep going and going and going. So this is actually worth 7 repeating. 7, 7, 7, 7, 7, 7, 7 until I run out of paper. That's another one that you're going to learn on the list. Okay. Now, I want you to practice a couple because it's always good to review long division. But if you've got a calculator or you pull one up on your Chromebook, you can simply type in 3 divide 8 equals. Even on a phone, on a tablet, anything that has a calculator, you just need the divide sign. All right. But if you can start to look for these, it will make life a lot easier and a lot faster. I can do a lot of these in my head in the time that it takes you to even turn the calculator on, just because I've been trained for the tricks. And we will talk more about that tomorrow.